Cool. So once you start getting more comfortable with this idea of proving that triangles are congruent, you can start getting into, I guess, trickier kind of proofs. And my tip is that when you're doing these for the first time or first couple of times, just have your tests handy, but also have an angles cheat sheet because it's very hard to remember them all. So having them on hand is a really good way to get started on these. Cool. Let's have a look at a couple of examples. So for these ones, they want us to complete the proof that the following triangles are congruent, and they want us to make sure that the vertices are matching. Okay. So it's a bit funny that you start off with the intro and they want the vertices matching. So one thing you might want to do is you want to start off by going through the reasons that we need to give first before we figure out which vertices are actually matching. Okay, so first thing I can see, AD is equal to DC, so that's given. I know that, so they want me to find what is equal to angle BDC. Well, I can see that's marked there, right? So that's where I want to be careful because I want to make sure the vertices are matching. So BDC, that needs to be equal to BDA, okay? Because I want that one in the middle there, but I want the other ones to be matching as well. And last one, okay, I know I've got an angle, I know I've got a side. Last thing I want another side. Well, I don't know anything about these sides on the bottom, but it's actually a little trick because this line, BD, that's shared between the two triangles, and the way we refer to that is BD is common. And obviously if it's the same line, then they're going to be equal. So what have I used? I've used a side, I've used another side, and I've used the angle in between. So I know that's going to be using an SAS proof. And again, I want to make sure that my vertices are matching now. So ABD, that's equal to CBD now. So it's congruent to triangle CBD. And I can fill it in up here as well. Cool. So yeah, if you start with your reasons first, that's a really good way to make sure that your vertices are matching. Cool, let's look at another one. So again, I've got two triangles that I can see, and I can see I've got a right angle here, but remember I want to make sure I have the hypotenuse before I say it's RHS. So let's look at what they give me. They want me to show angle ADC is equal to another angle. So I can see that one's 90 degrees. And I go over here and I say, okay, I know this one's 90 degrees. How do I make sure the vertices are matching? Well, I know that A is in both triangles, so I can start off with A, that's safe. So angle ABC would be equal to angle ADC there. Cool, what else do I need? Oh, I've got these sides here. So AB is equal to AD, and that's just given. And again, I've got a line that's shared between both triangles, so I know that AC, well, that's common. Okay, AC is shared between both triangles, so it's common. And I want to think, okay, what reasons did I just use? And I used an angle, I used a side, and I used another side. And so I don't have the included angle between these two sides, but in actuality, if I twist it this way, maybe it's a bit clearer. You can see I've got the hypotenuse because AC is the side opposite the right angles, and in this, so if this triangle here and this triangle here, if I rotate like that, you can see it clearer. That AC is that hypotenuse, and so I can use RHS. I can use RHS in this case, and I just want to fill this in as well. Triangle ADC. Cool. These ones are a little bit trickier. So again, I've got two triangles, but this time there's some sort of hourglass shape, and these are really tricky to make sure your vertices are matching. So I want to be really careful here. And this is where your angles cheat sheet is going to come in handy, because although for a lot of the sides that they usually give you those, the angles are not so clear to see. So I just want to first write down any information I can see, and they tell me, okay, BC is equal to DC, so that's given to you. Let's think about what else do we know. And you know that when you have two straight lines going across like this, that's when you create vertically opposite angles. And you know that vertically opposite angles are equal. So first thing I can realize, well, this angle here, DCE, is equal to angle BCA. And I don't want to just say given here because it's not given. They don't have any marks there. But I know because of vertically opposite angles, these are vertically opposite. That's why these two are equal. Okay, cool. I can mark that in now. Now, for the other one, this one's a little bit trickier. You have to come back to your cheat sheet and think, okay, what shape does this hourglass kind of resemble? And if you look a bit closer, you can realize, okay, I've got this kind of Z shape going on. And that's when you have alternate angles, right? When you have two parallel lines, so that these arrows mean that they're parallel. And you can see that I've got a Z going on like this. And if I look at this guy in particular, you can realize, well, this angle here is equal to this angle here, okay? And you can apply this to the other one actually as well, because if you have a Z going the other way, it'd be the same thing. I should put a mark there, so it doesn't confuse you. Okay, what reason did they want? They wanted angle ABC. So angle ABC, well, that one is alternate to this guy here, angle EDC. They already told me that. What's the reason? Well, the reason is alternate angles. Okay, great. And I know that I've used two angles and one side, and that's angle side. And just for the matching vertices, something I find helpful is that I redraw the triangles. So I know that angle C is equal to each other. Okay, and when you write it like this, it's a lot clearer to see, okay, which ones are matching now. So I can see that ABC is matching, or the vertices are matching to triangle EDC. Sweet. Let's do one more example. I really like this one because initially it's not so clear how to prove the triangles are congruent, but it's actually really quite elegant because, okay, so if you're given a circle here and they want you to prove that each of the triangles is congruent, you're told that O is the center, and initially you're only given, well, that you've got these two sides equal here. So you're not really sure what other information you can use. Let's write that down first. So I've got AB is equal to CD. What else do I know? Well, I might want to think, oh, okay, maybe I've got something like the vertically opposite angles going on. But that's when you have two straight lines crossing. And you can see here, well, these are clearly not two straight lines. They're all coming at different angles, so I can't really use that. But what you can use is you can use this information here. You can say that, okay, well, if O is the center of the circle, what are these lines coming up? Well, they go into the edge, so they must be radii. And the radii of circles are equal. So, from that, you could say, okay, well, that's easy then, because I know that this side would be equal to this side, and this side would be equal to that side. In fact, they're all equal to each other, so you could choose either one. So you could say AO equals to CO. So this one was given. And this reason was, well, radii of a circle. Okay? Once you choose those ones, then you can say, okay, well, what reasons do I have for these? Same thing. BO is equal to DO, radii of a circle. Okay, and those are your reasons. So what did I just use? I used that three sides in one triangle equal to three sides of another. So that's going to be SSS. So again, I want to refer to my triangles with the matching vertices. So you can choose any order, but triangle AOB, I just want to make sure I keep the order for the one I use, triangle COD. And so therefore, at the end, triangle AOB is congruent to triangle COD. And why? Well, I've used three sides, that's SSS. Sweet.